In this video, we will practice integrating quotients. Sometimes we use substitution, but other times we use inverse trig rules. So how do you know when we will do the inverse trig and when we will go straight to substitution? It's all about the degree of the numerator versus the degree of the denominator. In this case, for example, the numerator has a degree of 1 because we have just an x, that's like x to the 1 power. In the denominator, under the radical, we see that the degree is 2 because of the x squared. So the degree of the denominator beats the numerator by 1. When that's the case, we will do substitution. If the denominator wins by 2 or more, that's when we use the inverse trig rules. So substitution it is. Let's let u equal everything under the radical, and we will kind of see what happens. So u will equal 10 minus x squared. That means u prime will equal negative 2x. If we do that substitution, we get 3x over the cube root of u. Instead of dx, we write du divided by u prime, which is negative 2x. We notice that we have an x in the numerator and an x in the denominator. That leaves behind the constants 3 over negative 2. So I'm going to put my negative 3 over 2 in the front outside of the integral. So that leaves me with 1 over the cube root of u du. Let's rewrite this a little bit. 1 over the cube root of u is the same as u to the negative 1/3 power. In this form, it's easier to see the power rule of integration at work. So I'm going to write down my u. I need to increase the exponent by 1. So I am adding 3 over 3 right here. That's going to give me 2 over 3. And then I divide by the new power. Dividing by 2/3 is the same thing as multiplying by 3 over 2. But don't forget the negative 3 over 2 that I already have. So that's still here. So negative 3 over 2 times 3 over 2. And all of this is plus c. So this will give me negative 9 over 4. And u is 10 minus x squared. And we have that to the 2/3 power and then plus c. So this will be the final answer to problem number 1. Number 2, kind of strange looking. Let's jump in and try a substitution and just see what happens. I see that we have this radical x inside of the sine function. So that would be a good guess for what might be u. That means that u prime would be 1/2 x to the negative 1/2 power. So let's do that substitution and see how it turns out. So we will have sine of u divided by, and that's another u right there because it's the square root of x. Maybe I should leave it? I don't know. I'll think about it. Instead of dx, I will write du over u prime, and u prime is 1/2 x to the negative 1/2 power. So I have 1/2 x to the negative 1/2 power. Yeah, so I think I will not write u for this radical x. Instead, I will leave this. Radical x is the same thing as x to the 1/2 power. It makes sense to leave it like this because now I'm noticing that if we multiply straight across, x to the 1/2 power times x to the negative 1/2 power, these will cancel each other out. They make a 1, like x to the 0 power is 1. So I'm only going to be left with this 1/2 in the denominator. Dividing by 1/2 is the same as multiplying by 2. So I'm going to bring this outside of the integral as a 2. So now I have 2 times the integral of sine u du. Okay, when you divide by a fraction, you multiply by the reciprocal. So that's what happened right there. And we know that the integral of sine is negative cosine. So I'm going to now have negative cosine u plus c. Don't forget the 2, so we have this. Putting radical x back in for u, we have the final answer. Let's try some u substitution on this problem. I see 3 over x all up inside of the cosine, so let's let u equal 3 over x. I think I will write it as 3x to the negative 1 power though. Then u prime will equal negative 3x to the negative 2 power. So let's go ahead and do that substitution and see what happens. So we will have the integral of cosine u over x squared. Instead of dx, we will write du over u prime, which is negative 3x to the negative 2 power. X squared times x to the negative 2 power, these cancel each other out and make a 1. So that's just going to leave this negative 3 in the denominator. Because we are dividing by negative 3, when I bring this out into the front, it will be a negative 1/3. So I have negative 1/3 integral of cosine u du. Memorized rule here. We know that the integral of cosine is sine. So I'm going to have sine u plus c. And don't forget the negative 1/3 in front. So I have negative 1/3 sine u plus c. Putting 3 over x back in for u, and we have the final answer. Ooh, remember when I said that sometimes we use inverse trig functions, inverse trig rules, instead of just directly doing u substitution. And I told you we would do that when the degree of the denominator beats the degree of the numerator by 2 or more. And here I see that the degree of the denominator is 4, while the degree of the numerator is 1. So this is what I was talking about. Which one of these rules do you think we will probably use? I see that we have a square root in there, and it's a minus, so probably not arctangent. We have a constant minus the variable. So, the arcsine rule has the constant minus the variable. So I'm betting on arcsine. The arcsine rule has u squared, not the 4th power. So I need to rewrite this part so that I have something squared. So let's see what we can do. I'm going to have x and then the square root of 1 minus, I need something squared. So this will be x squared inside of here. All right, x squared squared, that's the same thing as x to the 4th power. And here I have my dx. Now this matches the rule, and we can see that in this case the u is x squared. So let's write that down. So we have u is equal to x squared, which of course means that u prime is 2x. Now how about the a value? We need to also mention that. The a value will always be the square root of this constant. So a is 1. So let's go ahead and do this u substitution. So I have x over the square root of 1 minus u squared. Instead of writing dx, I will write du over u prime, which is 2x. And then I notice that we have x in the numerator and the denominator. These cancel each other out. The 2 in the denominator will become a 1/2 in the front of the integral. So now I have 1 over the square root of 1 minus u squared du. This integral is now a perfect match for the rule. So we can go ahead and use the rule to integrate. So I'm going to have arcsine, and it's u over a, but a is 1, so it's just going to be arcsine u plus c. I do have this 1/2 in the front, so I will not forget to stick that on there. Putting x squared back in for u, we have the final answer. In problem number 5, the degree of the denominator beats the numerator by 2. That suggests that we will be using an inverse trig rule. Which one do you think we are going to use? I see the square root, so it's not going to be the tangent, arctangent. I see the constant minus x squared. So it looks like we are using arcsine again. This is already a perfect match for the rule. We even have x squared, so we don't need to do a u substitution. We just need to realize that a is going to be 2, because a will be the square root of the constant. So we can just write the answer, really. So we're going to do arcsine, so we can just go ahead and write down arcsine of u over a. Well, we didn't use a u substitution, so we're just going to do x over a, which is x over 2, plus c. And that's it. Kabam! When I first looked at problem number 6, I was not immediately sure whether I should do u substitution immediately or go to my inverse trig rules. The thing about degree here, in this case, it's a little bit harder to see, the degree of the denominator versus the degree of the numerator. But I really just did some trial and error in my head, and I'm deciding that inverse trig is going to be the way to go. But I wanted to show you the trial and error that I sort of mentally did. Because when I imagined doing u substitution, then what would happen is that I would say let u equal the entire denominator, because that's kind of the only way that this would even possibly work. So I would let u equal 1 plus e to the 2x power. And then u prime would equal, the derivative of 1 is 0, so ignore that. But the derivative of e to the 2x is e to the 2x, but you do have to do the chain rule and multiply by the derivative of the inner function. So that would be times 2. So let's see how that would work out. So I would do the integral of e to the x over u. And then I would, instead of writing dx, I would write du over u prime, which is e to the 2x times 2. And here's where the problem happened. I have this e to the x in the numerator, which I really need to cancel out. But then I have e to the 2x in the denominator. These do not cancel out, and I'm stuck. So this is why I just did this in my head, and I could see that u substitution was not going to work out. So instead, let's get these inverse trig rules into the mix. Which one do you think I'm going to use? Obviously, arctangent. I have no square root, and I see the plus sign, so there you go. In the trig rule, I have u squared, so I need to rewrite this as something squared. So here I go. I have e to the x power over 1 plus, and now here I need something squared that's equivalent to e to the 2x. Well, if I just put e to the x inside of here, this would be the same. when you raise a power to a power, you multiply. So e to the x squared would give you e to the 2x. So now I have my u squared, and I can specifically see that u is the e to the x power. That means that u prime will also be e to the x power. All right, that's our favorite derivative. The derivative of e to the x is e to the x. What about a? A is going to be 1, since a will be the square root of the constant. And let's see, I still have my dx. So let's go ahead and do this u substitution. So I will now have the integral of e to the x over 1 plus u squared. Instead of dx, I will write du divided by u prime, which is e to the x power. Oh, look at that. The e to the x in the numerator will cancel out with the e to the x in the denominator. So now I have the integral of 1 over 1 plus u squared du. This is a perfect match for the rule, so I will now use the rule to integrate. I see 1 over a, but a is 1, so that's 1 over 1, so I'm not going to write that down. Moving on to the arctangent part, I have arctangent. And then it's u over a, so that's really just going to be u plus c. Putting e to the x back in for u, we have the final answer. I can tell this will ultimately be an inverse trig rule situation because the degree of the denominator beats the numerator by 2. However, the presence of this trinomial tells me that I need to complete the square to get it ready. So let's do that off to the side. So I have x squared plus 4x. For my first step, I'm going to leave a space here before I put the plus 5. Because completing the square means I need a special number right here, and the 5 ain't it. So what's the special number? Listen to this phrase, half the middle squared. The middle number is the 4. Half the middle would be 4 divided by 2. I need to do half the middle squared, and then that gives me the special number. So 4 divided by 2 is 2. 2 squared is 4. So that is the special number that goes right here. That's the number that completes the square. I should put plus 4. All right. Now, I have changed the value of the problem by putting a plus 4 here. You can't do that. So I need to immediately balance that out by putting a minus 4 over here. So I've completed the square, but the point of doing this is that this trinomial will now factor as the same binomial twice. So this would factor as x plus 2 times x plus 2. Meanwhile, over here I have the 5 minus 4. Let's go ahead and put a plus 1. But let's not leave x plus 2 times x plus 2. Let's write this as x plus 2 squared. So I now have x plus 2 squared plus 1. So this expression is equivalent to this trinomial. So I will now rewrite the integral with this instead. Which inverse trig rule are we going to use this time? Obviously arctangent, because there's no square root and I have a plus and all, so arctangent it is. You might have noticed that I flipped this denominator around the other way to make it a better match for the rule. Anyway, it's pretty obvious that my u squared is x plus 2 squared, which means that u is x plus 2. That means that u prime is just going to be 1, so that won't change anything. The a value will also be 1, since the a value is the square root of this constant. If we make that substitution, I will have the integral of 1 over 1 plus u squared. Instead of dx, I will write du. Normally I would say du over u prime, but u prime is just 1, so that's it. This is now a perfect match for the rule. So I will use the rule to integrate. It says 1 over a in the front, but a is 1, so I don't need to write that. I will move straight on into arctangent. Arctangent of u over a. A is 1, so it's just arctangent of u plus c. Putting x plus 2 back in for u, and we get the final answer.